So that's imaginary. Guys, all rational numbers can be written as fractions. That's what it means to be rational. To be rational means that you can be written as a fraction. So whole numbers, just stick a 1 underneath them, it's a fraction. Decimals that end or repeat can be converted to fractions. Fractions are obviously fractions already. And then you can use variables inside of fractions, and that's what a rational expression is. It's a fraction with variables in it. Okay. So your most basic when we work on this, we're not going to need pluses or minuses. It's just going to be variables and numbers, maybe some exponents smashed together at the top and in the bottom. So if you look on your packet that I gave you guys on Thursday, 1 through 6 are the basics. Okay. Now, what you do when you see that, so let's say I have something like this, okay? I have no addition or subtraction. I can reduce this relatively simply. I don't have to do any work before I can reduce it, is what I mean. I'm not saying that the reducing is necessarily simple, but I don't have to do any pre-work to reduce. What you want to do is you want to look at each part that matches separately. So I'm going to look at the 6 and the 8 as one part, the x's as another part, and the y's as another part. And I'm going to deal with those on an individual basis to get my final answer. 6 and 8 will both divide by 2, so that's what I'm going to do first. 6 divided by 2 gives me that 3, and 8 divided by 2 gives me 4. Okay, so these are done. Okay, that's done. When I look at the x's, this is x to the 5th divided by x squared, and we're going to use our exponent rules for that. And when we divide common bases, we subtract our exponent, so it's 5 minus 2. 5 minus 2 is 3, and the 5 was on top, so the 3 stays on top. It's like tug of war. Whichever exponent was bigger, that's which side you stay on. Then when I look at the y's, I have a 3 and a 10. I'm going to do 10 minus 3, which is going to be 7, or 3 minus 10, which will give me that negative 7, but I can't have a negative exponent. So it has to be in the basement. So you can either look at it and do the subtraction, 3 minus 10, get the negative 7, put it downstairs to make it positive, or you can look at it like tug of war and do 10 minus 3, and 10 is bigger, so it wins, so the 7's on the same side as the 10. And then you just double check, and you make sure that you don't have anything else, like 3 and 4 won't reduce any further, and then you have only x's, there's no x's on the bottom, and there's no y's on the top, you want just 1, and then you're done. Get 30 and 5 divided evenly, so that's going to be 6, 5 minus 3 is 2, and then y to the 6th, then y to the 6th. They're both the same. So when I do 6 minus 6, I get 0, which means I have no y's. So that's that. It'll be done. These will completely cancel each other out. And if they were reversed, if the 30 was on the bottom and you don't have to put a 1 in the numerator. So we divided both of those by 5, but 1s don't count for anything when you multiply them, so you just. Any questions on these single, basic, with no addition or subtraction? Okay, if you look at number 7, I have 2r minus 4 over r minus 2. Because this has subtraction in it, I can't just look at the r's and reduce that part, and then look at the number part and reduce that. You can only do that if there's no addition and subtraction. Because there's this subtraction in the middle, I have to consider this whole numerator and the whole denominator. So before I can reduce them, I want to see if there's anything I can do to factor them. Now 2r minus 4, the 2 and the 4 have a 2 in common, so I can pull out that greatest common factor of a 2. So when I pull that 2 out, I'm left with an r here and a 2 there. So far okay? And then my denominator, I couldn't do anything with. It was just r minus 2. I can't take anything away from either of those except for a 1, and that's pointless. But when we look at this now, this r minus 2 and this r minus 2 match. And since they match, I can cancel them out. Because r minus 2 divided by r minus 2 is going to be a 1. Anything divided by itself is just 1, no matter what those things are. Triangle divided by triangle is 1. Okay. So these will cancel. And all I have left is a 2. Okay. Look at number 8. And when I look at this one, I could take a 10 away from the a's, correct? Okay, but I still don't have anything that matches. But I do have a whole number 45, and I do have a whole number 10 out front here. And both of those will divide by 5. So make that a 9, and that a 2. And that'll be your final answer. So sometimes it's not always obvious initially what exactly you should do, but sometimes it is. Okay, so when we look at this one, I have b minus 5, and then I have a quadratic formula on the bottom, the b squared minus 10b plus 25. And this we're going to have to factor into the 2 binomials like we were doing before, that everybody hated. The majority of the class seemed to like the table versus the X. Is that right? Any table people? Don't we remember what I'm talking about? X's. Okay, we'll do a big giant X then. Okay, we want to multiply and add, or that either way, adding, multiplying, those can flip over if you like it better on top. Multiplying to make the 25 at the end, adding to make a negative 10. So what can multiply together to make a 25 and add to make a negative 10? Negative 5 and negative 5. Because the 2 negatives will add up, or multiply to make the positive and add to make the negative. So, we didn't change the top. denominator is going to factor to v minus 5 times v minus 5. And one of these will cancel with the numerator. Now when that happens, I have nothing left up top. I can't just leave nothing up top. So you're going to put 1. Let's look at 14 next. When we have two quadratics, you're going to have to factor both the numerator and the denominator. So I need 2 x's. Okay, for the numerator, I'm going to multiply to make negative 30, and I'm going to add to make negative 7. So let's think about what we can multiply to make 30, negative 30. Yeah, 6 and negative 5, but when I add those together, am I going to get 7? No. How about 2 and 15? What was it? 10 and negative 3. Except, my 7 is going to be negative.
So the 10 has to be negative?
So the 10 is going to need to be negative. Does that make sense? That's why the 10 had to be negative?
Yeah.
Then for my next one, I'm going to have a multiplication of negative 24 and an addition of negative 5. So we think about what multiplies to make 24. You've got 2 and 12. That's a difference of 10. 4 and 6, that's a difference of 2. 3 and 8. Yeah, we're going to do negative 8, positive 3. So our numerator is going to be v minus 10, v plus 3. And our denominator is going to be v minus 8, v plus 3. And then we just say, okay, what matches? The v plus 3, so we're going to get rid of those. And we're left with v minus 10 over v minus 8. Now you might look at this and say, okay, 10 and 8 are both even, and want to do something else with them, but you can't. Because when you have a fraction like this, anything that you're doing in the top, you're also doing in the bottom, but you have to do it to every single thing. And since I can't divide these v's by 2, I can't divide the 10 and the 8 by 2 either. Does that make sense? So don't over process. Don't try to do more than you're allowed to. Let's look at the numerator first, and then we'll look at the denominator. Okay. We need to multiply to make a negative 18, and we need to add to make a positive 3. So we can multiply to make 18. 6 and 3, right? So I want my 3 to be negative because this is positive 3. So that's all well and good for the numerator. What about the denominator? Oh, you guys remember, yay! That's called a difference of squares. And so when you have a perfect square minus another perfect square, you take the square root of the first, the square root of the second, and then you plus and minus. Okay. And since x squared is a perfect square, and then 36 is 6 squared, so I have x plus 6, x minus 6. These plus 6's match, so they go away. And I'm left with x minus 3 over x minus 6 as my final answer. Is that legal? 15 divided by 0.
Yeah, it's gonna be 0, right?
No. 0 divided by 15 is 0. Because 15 times 0, 15 times 0 equals 0. Okay. If I rewrite this like this, what times 0 equals 15? Nothing, right? There's no number that I can multiply 0 times this number and get some other number, right? Okay, so this is not legal. We also call that undefined. Or we say it does not exist. Or you guys will say things like no solution, or you'll put in like the empty set. Just basically, no. So if somebody hands you a math problem sometimes and they're like, 25 divided by 0, you just look at them and go, no. Hand it back to them, okay? Because we can't divide by 0, that also means that none of our rational expressions, like the ones we just did, can have a denominator that's going to equal 0. Because it would then become an illegal math operation and can't happen. Okay, so no denominator. No denominator can never equal 0. So if I look at like number 1 on this excluded value page where it says 30k minus 20 over 90k. $90k cannot equal 0. It's not allowed. So when we are looking for excluded values, okay, excluded values are the values that would cause that denominator to be equal to 0. Sometimes there's 1, sometimes there's 2, 3, depends on what's in the denominator. But to find the excluded value, we take the denominator and then we solve it. So we set it equal to 0 and then we solve it. And whatever the answer is that we get from our equation that we created, those are the values that cannot ever be. So in this case, I'm going to say 90k equals 0, so that would mean k would equal 0. So our excluded value on this is k equals 0. K can never equal 0 for this particular rational expression. K can equal any other number on the universe, known and unknown, but it cannot equal 0. Okay, if we look at something like, do we have it? Look at number 3.
Wait, what about the top?
The top doesn't matter. You mean the numerator? Yeah, the numerator doesn't matter. The numerator can equal 0, that's okay. It's only the denominator that we're worried about, so when you're looking for excluded values, you just ignore the numerator and work on the denominator only. So like this one, we get 18 over 27x plus 27. Okay. I'm trying to find the excluded values, so I'm going to take my denominator, and I'm going to set it equal to 0. So I'm gonna subtract 27 from both sides. Should be different color. So I get 27x equals negative 27. Then I will divide both sides by 27. And then I'll get x is equal to negative 1. This is the excluded value. That's my excluded value. So that's the number that x can never equal.
Why -1?
Negative 1. Because if I plug in a negative 1 right here, I'll get 18 divided by negative 27 plus 27, which would give me 18 divided by 0, which is not allowed. Does that make sense? Let's look at number 6. Okay, if I'm going to solve that, I'm going to take that 14x squared minus 16x, so the whole denominator. So equal to 0. I have x's in both, so that's the greatest common factor that has an x in it, and then I have a 14 and a 16, and those will both divide by 2. So if I take a 2x out, 14 divided by 2 is 7. There were 2 x's. I took one away, so there's 1 left. And 16 divided by 2 is 8. There was 1 x. I took it away, so now it's gone. So that's factored. Whenever I factor, I have 2 things. I use that 0 product probably, so I set them both equal to 0. Okay, so once you factor the denominator, both parts equal to 0. Well, 2x is equal to 0, that means x equals 0. That part was easy. I come over here, I add 8 to both sides. So 7x is equal to 8. Divide by 7. And 8 doesn't divide by 7, and that's okay because fractions are cool. You may not like them, but they're perfectly acceptable as answers. Now you'll notice you got 2 answers. You have an x squared. X squared gives you the possibility of 2x. So in this particular problem, x cannot equal 0 ever, and x can never be 8/7. X can be anything else in the whole wide world except for those 2 numbers. Yeah. Yeah, because if I plug either of those in to the denominator, I would get 0.
If you did just one of them, would that be fine? Or would you have to list them both?
You have to list them both. Yeah. So if you only did one, you get half credit. Okay, and then we're going to skip to a more complicated one. Hmm?
What about
Number 4?
on this page?
The only time you need to worry about excluded values is if you have a variable in the denominator.
Okay.
If there's no variable in the denominator, then there are no excluded values.
Okay.
Yeah, that's a good point. That's a good question. The only time you worry about the excluded values is if there's a variable in the denominator. If the denominator is just like 5 or something, and there's no x, y, no variables, then there are no excluded values. because it's a variable that has to be in there that would make it 0. So if it's just 5, then you're good. No, it's not 5. Let's look at something like, let's say, I don't know, 23. Okay, I have p to the third, p squared and p. That tells me that there's going to be a possibility of 3 excluded values. So I'm going to set my denominator equal to 0. And on these, my first step is always going to be to look for that greatest common factor, the biggest number or variables I can pull out of everything. All 3 of these have p in them, so I can pull it out for sure. 21, 33, and 12 will all divide by what? 3. So I can pull that out. Okay, if I take 21 and I divide it by 3, leaving me with a 7. There were 3 p's. I took 1 away, so now there's only 2. 33 divided by 3 is 11. There were 2 p's. I took 1 away, so now there's only 1. And then 12 divided by 3 is 4, and I took away its only p. Okay, now I need to look and see if I can factor this. Or we can use the quadratic formula. Which would you rather, factor or quadratic formula? Okay, I have a vote for factor. Okay, so I'm going to do 7 times 4 is going to give me 28. And then I'm going to look for factors of 28. So give me a sum of 11, and oh, hey, look at that, I get 7 and 4, right? So I'm going to replace my 11 with 7 and 4, because those add up to 11, and multiply to make 28. From 7p squared and 7p, I can take out 7p, and I'm left with p plus 1. And from 4p and 4, I can take out a 4, and I'm left with p plus 1. So far, okay? Did I lose anybody? Okay. So that tells me 3p times 7p plus 4 times p plus 1 is going to equal 0. So I've got 3 factors, 3p, 7p plus 4, and p plus 1. So 3p will equal 0, 7p plus 4 will equal 0, and p plus 1 will equal 0. That one was easiest. Over here, I'll get 7p is equal to negative 4, because I'll subtract 4 from both sides. And then I'll divide by 7, and I'll get a fraction, and that's okay, because I don't have to do anything else with it after this. And over here, I'll subtract 1. So I'm actually going to get 3 answers. P cannot equal 0, negative 4/7, or negative 1. Anyone want to see the quadratic formula version of that?
Yeah.
Yeah. We will go from here on the next page. Anybody still writing this? Version missing. And if you don't like factor, you can do quadratic. You'll set this equal to 0 and get your 0. That'll be one part, and that part's done. And then you'll set this equal to 0. That's your other factor. And then you'll use quadratic formula. So this will be your A, this will be your B, and this will be your C. Okay, negative B, so negative 11, plus or minus the square root of 11 squared, minus 4 times A, which is 7, times C, which is 4, over 2 times A. $121 minus 56 over 14. Negative 11 plus or minus. 21 minus 56.
65.
Really?
Yeah.
Did I write that down right? 7, 11, and 4?
I didn't see. Yeah.
7, 11, 4. Maybe I didn't multiply right. 4 times 7 times 4. Aha, I didn't multiply right. That's what it was. Yes, it should not be 65.
Thought it, well, no.
I did 7 times 8 instead of 7 times 16. So 9. That makes more sense. So negative 11 plus or minus 3 divided by 14. Negative 11 plus 3 is negative 8. Negative 11 minus 3 is negative 14. Both of these divide by 2. Both of those divide by 14. So you get your 3 answers here of what P cannot be. Okay?
I think the other way is easier. This one's even longer.
This one's long.